So in this video, we're going to discuss even and odd functions. So algebraically, a function is even if f of negative x is equal to f of x for all values, for all x values. And what this means is that the negative x values have the same y output as their positive x values. So in other words, this is symmetrical, let's say, symmetrical across the y-axis. An example of this would be the parent function for a quadratic, y equals x squared. So if we look at a table, x and y, we have 0, let's say 1, and then 3, and then negative 1, and then negative 3. So this will be 0, 1 squared is 1, 3 squared is 9, negative 1 squared is still 1, and negative 3 squared is still 9. So these negative x values, the negative 3 and the negative 1, have the same y output as their positive counterparts, 1 and 3. So it would look like this on the graph. And then for a function to be odd, then f of negative x is equal to negative f of x. And we can look at an example again. Y equals x cubed, the cubic function, the one that looks like this. So if we have x and y, if we make a table, we have 0, 1, 3, negative 1, negative 3. So 0 cubed is still 0, this is 1, this is 27. Negative 1 cubed is going to be negative 1, because a negative times a negative times a negative is still a negative, and this is going to be negative 27. So these negative x values have the same as their positive, except they're negative. So odd functions are symmetric about the origin. And graphically, that means if we flip the function across this line y equals x around the origin, then it's still going to be the same function. So to test if a function is even or odd, we're given f of x. So we want to find and simplify f of negative x and negative f of x and see which two match. If the f of negative x and the f of x match, then it is even. If the f of negative x and the negative f of x match, then it is odd. And if none of the two match, then it's neither even or odd.